When we see clouds, they're condensing. When we see fog, and then also when we see, your example from real life is when water appears on the side of a cold drink or in a mirror when you shower. Condensation is not a matter of one temperature, but of a between two, the air temperature and the dew point temperature. At its basic meaning, the dew point is the temperature where dew can form. Actually, it's the temperature that if air is cool to that level, the air becomes saturated or cool. Any additional cooling can cause water vapor to. Foggy conditions often occur when air temperatures and dew points are equal. So the water in the air gets pulled out of the air and forms on a hard surface or forms on a surface. Condensation is the opposite of evaporation. Let me stop here because this is so important. So we have gas to liquid. And remember, evaporation is liquid to gas. Antonyms, these are antonyms. All right, since water vapor has a high energy level than that of liquid water when condensation occurs, the excess in the form of energy is, this release of heat aids in the formation of, so this whole process leads to our weather. Precipitation. Precipitation is a result when the tiny condensation particles grow through collision and coalescence for the rising air to support, and thus they fall to the earth. Precipitation can be in the form of hail, snow, or, all right. So when too much water in the gas form comes together or condenses, and this usually happens as it gets colder, it finally falls out of a cloud as rain, sleet, hail, or snow. Precipitation is the primary way we receive fresh water on Earth. On average, the world receives 980 millimeters each year over both the oceans and the land masses. So rain is the main way we get fresh water. Runoff. Runoff occurs when there's an excessive precipitation and the ground is saturated or cannot absorb any more water. Rivers and are results of, there is some from runoff into the atmosphere, but for the most part, water in rivers and lakes return to the ocean. All right, so when the ground becomes saturated, we get rivers and lakes. And all this water returns to the oceans, mostly. If runoff water flows into a lake only with no outlet for the water to flow out of the lake, then evaporation is the only means of the water to return to the, with only pure is, and therefore any contaminants or salts are left behind. The result is the lake becomes salty, as in the case of the Great Salt Lake in Utah or the Dead Sea in Israel. So when the water evaporates, it leaves the contaminants or salt behind. This is how we get salt lakes. Evaporation of this runoff into the atmosphere begins the hydrologic cycle over again. Some of the water percolates into the soil and into the groundwater, only to be drawn into plants again for transpiration to take place. All right, so we're going to stop and make our diagram really quickly. And I know you've seen these before, so I'm not going to spend too much time on the water cycle. You only have one question. Analyze what would happen if one type of organism, such as a producer, consumer, or decomposer, was removed from the world. How would it impact the water cycle? Provide at least two ideas. Analyze effect if one type of organism was removed. And remember, I need you to focus on the water cycle. All right. We're going to go to our diagram really quick to make sure we have a visual in our brain. It's our last diagram. All these diagrams are going to play a part. This is Friday, May 15th, and helping you with your community project. All right, so what do we need in our water cycle? We need some sort of a mountain. Remember, yours doesn't have to look exactly like mine. And we need some sort of a river, a lake, and even an ocean. These are all of our water landforms. And we need a tree or some sort of a plant. And what runs the water cycle? Sun. So can't forget to have that. And there's also people. Can't forget to have those. All right, and then we need some sort of a cloud. And remember, it can snow or sleet or rain. Lots of different types. Sun and cloud. All right, so when water falls from a cloud, what's the fancy word for that? Rain, sleet, hail, or snow? Precipitation. And when the snow melts and it runs off, we call that runoff. And it runs into surface water. Or it soaks down into the ground. That's how we get our water in our soil. And do you remember, in all this is surface water, do you remember what it's called when it evaporates out of the plants? And it starts with P. Oh, no, it starts with T because I think of trees. Transpiration. And it also comes out of people, and out of lakes, and out of oceans. What do we call that when it goes from a liquid to a gas? Evaporation. It's happening all over the earth. And when it comes together from the air, it comes together, it gets cold, it makes a cloud, and we call this what? Notice they all start with a C. Cold, come together, cloud, condensation. Cold, come together, cloud, condensation. All right, now your diagram could look totally different from mine. And it doesn't just start here, or just start here, or just start here. It can start here. It can go from the surface straight up to a cloud. It can go from the surface to the ocean, to straight up to a cloud. It can go from a plant to a cloud. So the majority of our Earth's water is going to be trapped down here in the ocean. And the next major amount of water is going to be in our ground and surface water. There's really very little water in the atmosphere, and there's really very little water trapped in plants and animals, even though we're 75% water. All right, and what runs this whole process? Hopefully by now you've learned we have been coming back and back to this. All these cycles need the sun. All right, this was our last reading diagram and video. So I hope you guys are having a great day, and I'll see you all on Zoom.